Join Dr Sarah Howard and her guests as they dive into the world of integrative veterinary medicine on the new Pure Animal podcast. Dr Howard interviews practitioners, researchers and industry professionals at the forefront of their fields with the aim of advancing pet well-being. Search for Pure Animal in your favourite podcast app. This is FX Medicine. I'm Andrew Whitfield Cook. Joining us on the line today is Dr Brad McEwen. He's a nutrition expert, naturopath, herbalist, educator and lecturer, researcher and mentor with over 19 years clinical experience. He received his Doctor of Philosophy in Medicine from the University of Sydney, a Master of Health Science in Human Nutrition from Deakin Uni, amongst other qualifications. Brad has numerous original research and review articles published in peer-reviewed journals, and he's also a peer reviewer for international journals. His research interests include the effects of diet and nutrition on cardiovascular disease, type 2 diabetes, cardiometabolic syndrome, depression, anxiety, polycystic ovarian syndrome, cognition, chronic diseases, sports nutrition, omega-3 antioxidants, chronic disease prevention and public health. Brad has a strong passion for seeing people succeed and achieve their goals. He also enjoys chocolate. Welcome back to FX Medicine, Brad. How are you?
I'm very well today. How are you?
Good, thanks, mate. Now, today we're going to be talking about something which I'd like some help on, pyrrole disorder. So in the recent years, there's been a lot of social media attention and even clinical attention given to pyrrole disorder. But let's go back in time. When did this disorder or the naming of this first appear?
That's a very good question, because a lot of people think that it is a new disorder, but there's a lot of literature showing, in the past, even back as far as 1929, 1935, 1936, showing up about, what are pyrroles? Because you'll find that the condition itself is typically referred to or colloquially referred to as pyrroles, which is incorrect. So one of the interesting things we're finding is that for over 100 years, scientists have been researching, different molecules that they find, and they've found these porphyrin-based compounds, and it's available in all different organisms, not just humans. They've been finding them in plants. And what the molecules are, they're talking a little bit of biochemistry for a second. They're these compounds that are made up of 4 pyrrole subunits. So I want you to think of like a spider's web or a net. And the pyrrole subunits hold a lot of molecules together. Now, fast forward briefly to today, a lot of medications are actually made with a pyrrole subunit to actually bind up the chemical structure of the medication. So if we look at the history, the word pyrrole has been named for over 100 years. They've been looking at a lot of research in the presence of how this actually combines with aldehydes and other molecules to form chemicals and molecules in our body. And one of these molecules actually is chlorophyll in plants, which I find quite interesting. It's also found in the heme. So, the hemoglobin in our red blood cell. So it is a molecule that is quite readily available in nature, but also readily available in the body. And the body actually, I won't say produces these molecules, but it utilizes these molecules to, for example, make red blood cells or bind up other proteins and use it as a structural net. I find that quite interesting. Another area that they do look at is heme, as I was saying, and even vitamin B12, which I'll talk more about in a moment. So the interesting thing is pyrroles are natural, to use the term pyrroles. They're capable of forming all these different bonds and sort of aldehydes, carboxyl groups, hydroxyl groups. And a lot of the time, the pyrrole may actually be in the nuclei of the molecule or actually be like in the spider's web, binding it all together.
Right.
They're also able to combine with other metals and minerals such as cobalt, iron, and magnesium.
Can you expand further on these minerals? So you've got cobalt, iron, magnesium in chlorophyll, iron in heme, cobalt in the cobalamin molecule. Any others, or can you expand further on them?
These are the main ones. But what we're finding with new research, because the research really started to take off in the 70s when they're finding elevated pyrroles in people's urine with schizophrenia, for example, and I'll talk more about that in a moment. So the interest to pick what else do these molecules do. So it actually does bind with the cobalt molecule in the structure of vitamin B12, binds it and holds it together. And I want you to think that cobalt is in the central core of the B12 molecule. And going back to the statement as an example of a spider's web, holds the cobalt within the B12 molecule. Now that could be a cyanocobalamin or the activated form of methylcobalamin, for example. Whatever form it is, it actually holds the structure of that cobalt within the B12 molecule. The heme one is actually really interesting here where, as we know, heme is generated by iron molecules being put together into this structure, which is heme. But this is actually a tetrapyrrole structure, so it has 4 pyrroles holding together the heme within the molecule, the iron, I should say, into the molecule of heme. So again, it's like this spider's web, structuring and holding it together. Iron is involved, of course, with hemoglobin, myoglobin, catalase, cytochromes, and other enzyme pathways in the body. And the pyrrole molecule seems to be able to hold it structurally intact so it can do its job. So there's a lot more structural and functional aspects to the pyrrole molecule, but what we're finding interesting is it's actually able to hold things together much more effectively. So hence the using it in medications.
Do you remember the not too distant, quite recent issue with cobalt toxicity from prostheses, from hip prostheses?
Yes.
Do you find, or has there been any research done looking at increased pyrroles to in the body's attempt to trap the excess cobalt?
I haven't seen any of that literature, but it's a very interesting question. One of the things you will notice, though, is pyrroles, the molecule reacts to oxidative stress and inflammation and can actually create it as well. So thinking of the cobalt in the hip replacement, in that actual structure of the metal, being, let's say, leached out into the system, I suspect the person's pyrrole content in the urine, which I'll talk about testing later, will increase because any kind of inflammation, stress, physical, mental, emotional stress, or oxidative stress in a person increases the pyrrole content.
Yeah.
So I haven't seen any research on that, but it'd be quite interesting because these hip replacements and joint replacements are a relatively new thing. And, of course, it's foreign to the body.
Yeah.
So it would actually be interesting to see how the body responds. We already know it's inflammation, but how the body responds biochemically with pyrrole molecules and other molecules that are similar.
So I guess we need a definition here. What is pyrrole disorder? I've got a secondary question there, and that is, do you think pyrroles are a target or a marker of something else going wrong?
That's a very good question. To date, there is no real definition of pyrrole disorder.
Right.
If you actually look it up, and I mean like up in medical journals, etc., you find it in a lot of social media where there's a lot of claiming of the disorder, and it's very copy-paste, which upsets me a little bit as a practitioner. But the way I describe pyrrole disorder to me is it's a very complex biochemical disorder. There's a lot of things going on. And sometimes I actually change the words around, as in disordered pyrrole metabolism. Because one thing I want to remind everyone is everyone has pyrroles. It's a natural molecule, and the condition itself has several different names. It's referred to colloquially as pyrroles, pyrroluria. It's actually misspelt several different ways.
Yeah.
So the proper way to spell it is Pyrrole. I've seen it with a double L and a double E and a double Y. And that's because there's no set standard on the disorder itself. I'm sure we'll see it in the next 5 years because it's becoming, I use the phrase, more popular. It's more popular to have. So we'll find a proper definition. But the way I look at it is a real condition. It is disordered pyrrole metabolism. And it can actually be tested by measuring the urine, and I'll talk more about this in a moment, by measuring a molecule called HPL. And the HPL stands for hydroxyhemopyrrolin 2,1. And sometimes, it depends on what textbooks that you look at. It's quite a long one. And what this is a hydroxylated form of a pyrrole molecule, of a lactone. So it's quite a complex molecule. And the way how it works is, the body responds to a stress, it gets released, and it goes through the urine. But what I'd like to do is, if I may spend a little bit of time briefly talking about what the HPL molecule is.
Yeah, please do.
Perfect. So the HPL molecule was first detected in the late 1950s. And it was originally called Mauve factor because of the colour of it. So when they investigated, because when you think about it, we've had a long history of measuring substances in the body. If you go back over hundreds and thousands of years, there was even like diabetes. You took someone's urine, had a bit of a smell, which we don't think about right now. And that if it was a sweet smell, for example, they termed it diabetes mellitus or sweet urine. So we've always been interested in measuring different molecules. And there was this research done in the late 1950s that found a higher incidence of this Mauve factor in the urine of psychiatric patients. So they had like bipolar disorder, very severe schizophrenia. And what they did was they measured all the patients that were in this institution and found out the ones with the higher level of psychiatric conditions, so to say, had higher levels of this Mauve factor. So it's sometimes referred to as that, but the proper terminology is HPL, or the hydroxyhemopyrrolin molecule. There's actually another molecule in the urine called Kryptopyrrole, which mistakenly gets used as a marker.
Yeah.
The HPL, they're very similar structural markers. And currently there's research going on in Australia, around the world, measuring urine of people who are healthy and who have all different mental health issues. There's, I think, one going up in Queensland as we speak. And they're looking at, do these levels change? And as far as I know, they're looking at all the different molecules. So it'd be interesting to see if the HPL and the Kryptopyrrole, which are definitely different molecules, actually increase. Now, the interesting thing with this molecule is it can show up in a number of different health conditions just regularly. Someone with iron deficiency can have an increase in the HPL molecule because they're not producing enough red blood cells, so the red cells are getting older, being broken down, and then being excreted through the urine. Unstable hemoglobin, they may have had some kind of accident, or hemolysis, may have had surgery, it's increased. The interesting thing about this molecule, it's very highly labile. It's very hard to study. It's unstable outside the body. Exposure to light, sunlight, reduces the detectability of the HPL molecule. If you don't use the right tubes at the lab, if it's not covered by, these are all the different things that can change it. So any kind of light affects it. So effectively when you collect the urine from the patient, it has to be in a darkened room. And then effectively straight away put into a collection cylinder,
covered with foil. Yep.
Yeah, put the foil around it, several layers of it because the light can still get through the foil. Then you have to refrigerate or even freeze it until it gets to the storage site for it to be tested. And the interesting thing is the molecule breaks down over time. So if you actually have a sample collected on a Thursday, Friday, and it has to go to a lab, it may be sitting in a collection centre from over the weekend and then gets sent off on Monday or even Tuesday, and the sample's pretty much, it's not going to give you an accurate reading. So we always suggest people to go and get a collection sample maybe on a Monday or Tuesday, like earlier in the week. That way, at least you know by the end of the week it's gone to the right centre. And a lot of collection centres these days are very good because they can speed up the samples, as in sending them off quickly.
Yeah.
But they are very unstable, and heat, light, even if you shake it, like if you put it down in the container too rough, but not throwing it down, but, putting it down quite heavily, that can actually destabilise the molecule. So it's like if someone's collecting blood to measure platelets.
So to me, like,
and they throw it.
Sorry, to me, like, that just makes the testing almost untenable, because you can't guarantee what's going to happen in freight. There's so much that can go wrong with user collection. So to me, I guess that really explains to me why the test itself is frowned upon by orthodox medical people.
Frowned upon. Yeah, and because there's no stability data on it, so to say, the safety, like, is the person stressed going into the test? The stress releases pyrrole molecules, so that can increase it. They may have run to get their collection. They may have had to run to urinate because they've got a weak bladder, and
bouncing up and down.
That's right. All these kind of things increase the levels, and I'll talk about the test now further. Typically in Australia and other countries, they look at around about 2 to around 20 micrograms per litre. That's what they're looking at with the amount that in the urine. Now, the issue with that, and that's been a standard for like 15 years, the issue with that is everyone has pyrroles in their urine. So everyone has the condition pyroluria based on definition.
Yeah.
But any kind of stress, tiredness, poor diet, anything can alter the test. So whenever I look at a test result, and let's just say it's 20 to 25, I just look at it and go, okay, good, thanks. Do you know what I mean? Because it's sort of like, oh, yes, you got detectable HPL molecule in the urine, you're under a little bit of stress, that's okay. But if it's 50 and above, that's when I actually start, thinking about it, because, the half-life of the HPL molecule is 10 to 12 hours. So every 10 to 12 hours, the content in urine decreases. So if someone has a level of 50,
it was higher, test, right?
It could have been 100, for example, or much higher.
Right.
But if someone comes to me and it's like a level of 10 or 25, yes, it would have been potentially much higher. But based on our knowledge of half-life, the lower number would have been very high to start with, because the sample has been collected in the last couple of days. So we can say it's relatively safe as a diagnosis. If someone comes in with borderline, they wouldn't have been that high to start with. But I've seen numbers very high. I'll talk about research in a moment, but I've seen numbers of 100, 200, 300, for example. And these people are perfectly healthy.
Right.
So it's a weird thing how people utilise one test and then go, okay, you've got pyrroles. And although they actually are correct, they actually do have pyrroles as in the molecule.
Yeah.
They may not actually have pyrrole disorder.
Yeah.
Because any of those factors we just talked about could just change those results. And that's why we need more trials on healthy people versus, people with anxiety, depression, schizophrenia, chronic fatigue, like all different health conditions and different ages, just so we can start getting baseline numbers like what they've done with liver function tests and red blood cell counts over the years. It's an accumulative data. Once we have that information, we can then turn around and say, now we've got a test that's got some validity behind it, and we can utilise it. I'm not saying don't use the test. I'm just saying don't rely on one test. If it's really high or really low, retest in a couple of days. Yes, it costs money because it's not covered by Medicare, but if you're focusing your treatment plan using this disorder or this molecule, which I suggest people don't, it's quite tricky just to base it on one test.
To me, it smacks of a test that really should be done in the clinic. To me, it's kind of like, using the whiff test to look at bacterial vaginosis. It's done right there and then. You don't send that test away. You do it there. You use other tests to confirm or deny it if required. Usually that's a clinical presentation, I get it. But I can fully understand why orthodox medical practitioners would poo-poo this test, because they can't reproduce it. There's no standard. There's no stratification of normal versus ill. So how do you use it as a benchmark for treatment? It becomes artefact. It
does. There's a big artifactual result with this. I want you to imagine that this is quite an emotive topic, because people are normally stressed when they come in with this because they've read it online or something. And let's just imagine you've gone to a GP, you've gone and got a liver function test. Get your blood collected. You go back tomorrow, get your blood collected. Go back the next day, get your blood collected. It's going to be relatively stable reading, would you agree?
Relatively.
Do you know what I mean?
Yes.
Relatively stable. It's not going to change too much. But if you did this with the urine test for HPL molecule, it is directly based on what they're doing that day. So if they have a far more relaxed day or a day running around, it's going to change the results. They may have an emotional stress that day, find out they didn't pass an exam, or, you know what I mean? Like,
untenable.
Traffic.
No reproducibility. Yeah.
No reproducibility. It's going to change most days. And if the results change plus or minus 5%, I'm just making that number up, for example.
Yeah.
I'd be relatively happy with that, because plus or minus 5% of someone with a reading of 50 is not that much.
Mm.
But if someone comes in one day and they've got a level of 50 micrograms per litre, tomorrow it's 25, the next day it's 100.
Yeah.
That to me, yes, it is related to, it's a good marker of ups and downs in someone, but we can't actually just treat based on that one molecule.
Yeah.
We have to look at a lot of other tests.
As you say, like, you could understand a certain variance from, different pieces of equipment, from even different labs using different reference ranges. They're not wildly different, but you will get some difference. And then, of course, you get the expert clinician that can pull apart a test, line it up with the clinical picture and go, that's rubbish, do the test again. And I've seen that.
That's it. And labs have, like you said, all different reference ranges, different equipment. And that's because the test is not a regular test. Not everyone can do it.
Mm.
So you're relying on, let's just say, a handful of labs who can do it effectively. And that doesn't allow for consistency of results.
Nor, obviously, testing in the clinic.
Testing in the clinic.
Yeah.
So if you did it in your own clinic, you're not going to have the equipment to start with to measure this, because it's the chromatographs and, it's expensive equipment. So they're not able to easily test for it in their own clinic. And then it's up to the clinician if they did it right. So there's variability between clinicians as well. So I think with research, we need to really, if we want to delve deeper into this health condition, because it is real, we need to actually start looking at a handful of labs, sending off multiple samples to those labs, and doing the old consistency test.
Yeah.
So you have one sample, send the required amount to 5 labs under Joe Blogs or whatever. It's not the right way to do science, but split sampling, send it all off and get the information done. And one of the things that does concern me is with the results of this, not scientific research, but online research, as people call it, is with a lot of genetic tests, because some people are calling pyrrole disorder genetic because it can pass through families. People are not giving the right information. I've seen, 50-year-old or 40-year-old female, for example, give the test samples of her own blood or urine, for example, or saliva, and write down her 10-year-old daughter's name on it. So therefore, we got a perimenopausal female with the age of 10 on the test result, and the labs are going, what's going on with these hormones? And now they're collecting data.
Yeah.
It's quite rife in online land with the misinformation of tests and people worried about their tests being hacked or something. So, this is where we need to have the research done with proper scientific research, so to say, universities, hospitals and labs all working together and actually, thinking about this test, what is the validity of it, what is the specificity, are we measuring the right molecule? The old questions we always ask, what is the proper range we're looking at? Because everyone does produce pyrroles in the urine. There is enough information on that. But should we be shifting up that 2 to 25 reference range to maybe 25 to 50 or below 50 as being normal, for example, or within reference range? Because a lot of the tests, I don't do it with a lot of patients because I already expect it's going to be in there because just due to person's stress. But anything under 50, as I was saying earlier, I don't really use it as a treatment goal.
So are there any surrogate markers that you'd use instead of this, or additional markers? On the basis of what you've told me today, I'd be going, you want the patient to pay money for this and it's not repeatable. How are you then going to say, I'm going to do another test and you're better. Like how do you then verify? How do you ratify it?
That's right. Like, how can we verify these tests? And that's what concerns me. We've got some people, qualified and unqualified, using this test that is relatively expensive because it's not covered by Medicare. And they keep sending them off for tests and keep prescribing hundreds of dollars worth of supplements in the hope this person gets better, like a shotgun effect, because the test itself is not giving you a lot of information. So what I'd like to do, I'd like to answer your question about surrogate tests, but I'd also like to talk a bit more about the research that has been done, which then leads us to our surrogate tests. So around the world, there is research on pyrrole disorder and its effects, particularly with mental health, but these are done in small selected groups. There's the Walsh Institute in the States. There's a couple of centres in Russia, but they're sort of spread out, but smaller groups. And they're, let's just say, a handful of research institutes doing the research, which to me I think is great, but it's not enough data to actually turn around and say, this is a condition we need to invest more in, of course, but also with the treatment aims. So thinking nutritionally first, to answer your question, with the research that's been done, they're looking at, the HPL molecule in the urine, and they're looking at other markers such as vitamin B6 and zinc, for example. Because what you'll find that's very interesting is the HPL molecule, the pyrrole, I should say, the pyrrole molecule itself, has an affinity for vitamin B6 and for zinc. Yeah. Now, what it does, it utilises the vitamin B6 or the activated form of vitamin B6, pyridoxal 5-phosphate or PLP, to metabolize the pyrrole molecule more effectively. So what that does actually, let's just say, uses up a little bit more B6 in the body and can bind it up as well as part of the molecule as a structural and functional unit of the pyrrole molecule. The pyrrole molecule also, as part of its metabolism and structure, can use up 8, let's call them molecules of zinc per pyrrole. So if you think about it, a molecule of zinc is quite small. And when we look at clinical practice, we might prescribe 30 milligrams of zinc. That's not a molecule. That's just a dosage of the zinc. Mm. But if each pyrrole molecule starts collecting up 8 molecules of zinc, I'm just trying to think of a better way to explain it, but we're effectively using up 8 molecules of zinc for every pyrrole that's not being metabolized effectively, and also binding up vitamin B6. So with the tests they've been doing, they've been finding relationships with the higher the HPL molecule in the urine, the lower amount of vitamin B6 activity in the body itself, particularly in red blood cells. They've also been looking at higher levels of HPL molecule in the urine and lower levels of concentration of zinc in the red blood cells and the white blood cells. This can lead to anemia in the future, weakened immune response, colds, flus, chronic fatigue, etc. And they're also finding it a relationship with glutathione. Now, as you know, glutathione is an antioxidant and sort of detoxifying molecule. So again, the higher the HPL molecule, the lower the plasma content of glutathione. And some of that research is very highly significant, like p-values of less than 0.0001, kind of significant level. And they've also been finding, just a slightly abnormal HPL level of urine, in the urine, I should say, there's a lower level of normal range of glutathione in the plasma. So they don't have a glutathione deficiency as such, because you can have that as a health condition, but it's at the lower end of the reference range of glutathione. And then the person gets an extra stress or something else is happening, and that really affects them. Yeah.
I guess conundrums within themselves, because, like, for instance, zinc is compartmentalized. So the analogy is looking at a car park in a shopping centre does not tell you how busy the highway is near it.
That's right.
Yeah, so I'm just looking at a paper here. It's an older paper, Rapid Screening Test for Pyroluria, 1R, useful in distinguishing a schizophrenic subpopulation. This is in the Journal of Orthomolecular Psychiatry, January 1974. First author is Soler, Sohler. And what they're looking at is these other acceptable urinary markers like urobilinogen.
Yes.
Should we be looking at this?
And that's a very good point, because when we look at the high levels of HPL or pyrrole distorted metabolism, it can lead to anemia because it affects the iron metabolism because of the heme component as well. So any kind of red blood cell test could start giving you an indication. The urobilinogen content can also let us know. I always ask for a plasma zinc serum copper, because what I'm looking at is, are they within reference range? And I can hear people right now debating me listening to the podcast. Is the plasma zinc serum copper within reference range? If so, whereabouts? Because we're looking at ratios as well.
Yeah.
Now, if someone has a lower end zinc, higher end copper, it's still within reference range. I will always look at wherever it's sitting in the reference range. But when it starts becoming out of balance further, we are looking at the conundrum of the zinc molecule being uptaken more with the disordered pyrrole metabolism, and the copper as an inverse relationship with the zinc increasing, because zinc metabolizes copper and copper metabolizes zinc. There's that symbiotic relationship with these two minerals that people forget about. They actually need each other for metabolism. But when the zinc deficiency occurs, copper levels go up. And then when the copper level goes up, not able to metabolize the zinc effectively because it's too high, leading to oxidative stress, which then leads to more pyrrole molecules or HPL molecules being produced, and so on, is that turning cycle. And what we're finding is that this binding up of the zinc and B6, among other nutrients like the heme that we're just talking about, can further amplify this condition by leading to further deficiencies, which then leads to other metabolism issues. So I can follow on from that study that you just talked about, because a lot of the research is actually based in, let's just say, more severe psychiatric conditions.
Yeah.
So there was a study that found the level of HPL molecule was higher than 20 micrograms per deciliter. I said liter earlier, sorry, it's per deciliter, 20 micrograms per deciliter. What we're looking at here, they had 48% had ADHD of those patients. There was 22% had schizophrenia, 30% had bipolar and depression, and a further 26% just had random diagnoses of just like stress and anxiety, etc.
Right.
And this is with people just within the range of what we classify as healthy as 2 to 25. So again, going back, is this marker useful if people with severe or serious health conditions show up within range?
Yeah.
There was another study where, and this one's quite interesting, there was a study that had a couple hundred people, 66% male, 34% female, which makes sense when they're looking at ADHD as well. The age range in the study was 2.7 to 25 years of age. Let's just say 2.5 to 25 years of age. They were followed for a bit of time. 65% of those patients had a level higher than 20 micrograms per deciliter. So again, a large proportion of the people had higher than the reference range already is.
Yeah.
The highest level was in that study was a 10-year-old boy with 481. A 5-year-old girl had 192. So there's actually quite high amounts. And this is where it gets a bit emotive for some people. They see the high number and they get stressed and freaked out if it's their own child or themselves. I've seen these high numbers and the person, I'm going to say to you, is relatively healthy. They don't get any colds, flus, there's no fatigue, there's no relatively stressed, of course, like everyone on this planet. But there's actually no physical, emotional, or mental stresses on this person that's representing, but they have higher levels. So is the test invalid in that person? Do they get a bit light or something on it? Or do you know what I mean? Like,
yeah,
were
absolutely.
they stressed running in? Like, one of my favourite examples is someone's running late for a blood test. So they're driving, they're stressed, they park the car, they're running, get their blood collected, and their platelet activity and platelet counts up through the roof because they've activated everything because they're running away from that saber-toothed tiger or the fight or flight response.
Yeah.
Same thing with this. But I will say there is a handful of conditions that have actually been associated with elevated HPL.
Ah, okay.
So there are ones that actually have been. That is ADHD, general aggressive behaviour, so people that are aggressive overall. I'm going to call that road rage. Explosive anger, bipolar disorder, depression, schizophrenia, and some of the studies called it poor stress control. Now, that interests me because everyone has stress in their life, but with the patients that had poor stress control, so they felt the stress more often, they felt it at a higher level, had elevated levels of HPL. So that's the handful of conditions that have actually been associated. Now, if I give you the list of signs and symptoms of what people call pyrrole disorder online and in clinical practice, it's going to blow your mind because it's abdominal tenderness. Explain to me how that comes through. I'm going to think it's a neurological link with B6 and zinc, synapses, etc. Acne, alcoholism, allergies, irregular periods, anxiety, ADHD, which of course has already been shown. Autism's a big one that they're linking, and there has been some smaller research on that, but not enough at the moment. Coarse eyebrows. That one interested me. Cold hands and feet, constipation, crime and delinquency.
These aren't a lot of these aren't conditions; they're symptoms. That like aggression isn't a condition; that's a symptom.
That's right. Migraine, light intolerance, impotence, hallucinations, obesity, nail spots. Like there's a huge list.
Yeah.
And when you look at this, and I say to you, poor dream recall, we start thinking of vitamin B6 deficiency. We start looking at this list of morning nausea, intolerance to smells and odours and sound. These are all like zinc and B6 deficiencies. So what's happening over the years, people have been accumulating data of what they think is pyrrole disorder, putting all these symptoms and signs together and packaging it up as pyrrole disorder. But if we go back to the research is not showing that.
No.
The limited amount of research is showing those, aggression, anger, bipolar, depression, schizophrenia. It's showing those conditions.
Mm.
So, and that's what concerns me is that the signs and symptoms I just rattled off have not been confirmed or linked to elevated HPL levels in clinical trials. This is all coming about from websites and clinics, and it's good that people are doing their own research and linking it up. But my concern is a lot of these conditions, like for example, saying obesity is related to pyrrole disorder, it doesn't make sense to me to say that. And it's on a lot of websites because I looked up, like the first 50 pages on Google, like in the last week, and all the different health conditions. And it's just amazing me what people are saying. And then, of course, they have the cure for it, which is a different story.
Yeah, whole different story. I love that.
Whole different story.
I hate that word cure. Right. I hate it when people use that.
I do too. And the word cure is real, like it is something that can be done, but it's very hard. Yeah. And to say that you can cure these signs and symptoms by clicking on the box next to the symptoms is it's heartbreaking because people are highly stressed and they read that and then they stop their medications or stop going to healthcare practitioners and follow this advice of this maybe overly priced supplement.
Mm.
Now, supplements are not cheap. I will say that. Whether it's a highest quality or an average quality, it doesn't matter. Supplements are not cheap because you need to go and buy that above your normal diet and lifestyle and everything else that you do.
And they're not subsidised by the government, so you're paying full price.
You're paying full price. But one thing I will say to you, they will work. If you get the right supplement and the right dosage, the right nutrient, the right formula.
For the right condition.
It will work.
Rather than
symptom. The right condition. The right condition. And that's where it gets very tricky because you need to really break it down with the person in front of you. And this is for the practitioners and patients and everyone listening to this podcast is when you look at the pyrrole disorder, look at the valid information out there. I'm trying to present a balanced view on this one here because I do strongly believe that disordered pyrrole metabolism is a health condition, pyrrole disorder, and it's overly, diagnosed like MTHFR. massive amount of diagnosis, yet everyone has the enzymes, so everyone's diagnosed with MTHFR. Candida, Th1, Th2 imbalance, homocysteine. Like in the last 20 years, there's been so many popular health conditions, and this is the latest one. But the interesting point is that I'm making is each one of these conditions are real when it's properly diagnosed and when you work out the proper symptom picture. So what I'd like to do is, try and help everyone listening to this podcast with a bit of a checklist of what you can do. So when getting the test done, make sure there's no nutritional supplements up to a week before going for the testing. Because if you go and get the urine test done, you don't want to have any kind of nutritional support, so to say, interfering with the test results. Also, any zinc, B6, or any other similar nutrients that are found to be deficient in pyrrole disorder, even iron, etc., they need to be stopped because they could alter the plasma and serum content as well.
Yeah.
Make sure that you're relatively not stressed, and take your time getting there. Make sure you have enough water so you can produce urine, so you can do the proper urine test, but don't drink too much. If you drink too much, you can overhydrate, leading to diluted samples because you've got more fluid in the body, and don't underhydrate because then you don't have enough urine and it's more concentrated. So there's another artifactual result. Check the room that it's tested in, make sure there's minimal light, and make sure the samples are wrapped in aluminium foil pretty much straight away and stored, and take note of earlier in the week. Everyone expresses HPL, so we need to look at the content in there. And if anyone's had stress in the last couple of days before the test, there's two things you can either do. Cancel the test and wait till you're relatively much better. Or what I normally suggest people do, if there's any kind of physical, mental, emotional stress, go and get the test done. And then when you're feeling much better, go and get the test done again and compare the pairs.
Yeah.
Because if the test results are very similar on your high stress day and your no stress day, the test has not given you the results that you're looking for. But if it's 3 times the amount on your stress day, for example, you know that your body has responded in kind to that stress. So with my checklist, I normally look at anything above 50 micrograms per deciliter, and I do apologise to everyone earlier, I said litre instead of deciliter, because then that should allow for the little elements of being stress driving there and relaxed. So normally when you go to a collection centre, they make you sit down for 10 minutes first. Have you ever noticed that? There's no one else there and you sit down waiting your turn.
Yeah.
That's to allow your body to start to rest so it's not as reactive. HPL is always present, so we need to look at the above 50, for example. Any kind of stress, mental, physical, emotional, elevates it, so we need to write that down in our case notes. I don't rely on one test. I may look at 2 or 3 tests, which now gets more expensive. But what I'm looking at is on a high-stress day versus an average day to a really calm and collected day if you've got it. And Excel is your friend. If you can fly through all the... Some people don't like Excel, that's fine. But as a practitioner, Excel is your friend. I use it a lot.
Learn how to do graphs.
Learn how to do graphs. I chart it in the patient's Excel sheet, convert it to a graph, and show them. And then what I can do, I can input the data on their plasma zinc, serum copper, their red blood cell count, platelets, whatever else I've tested, put it into the one Excel sheet, into the one graph, and show them the beautiful flow of how their body works. So we've also got females with the menstrual cycle. They use up more iron, for example, and B6 and zinc related to menstruation. So therefore that's going to affect it. So when in the part of the cycle do you test for it? No one has said to do that when you actually look at the cycle. Men have a cycle as well, like the andro cycle. It's a little bit harder to map, but you can just look at the anger. As in the male's a little bit more sort of frustrated when sort of adrenaline and cortisol levels go up. Impatience is rife. And of course, you've got menopause and andropause. So you've got older people where it can be effective. Look at the plasma zinc and serum copper. For example, plasma zinc is around about 12 to 20 micromoles per litre is the reference range. I'm very comfortable with that reference range, anywhere between, based on supplements, diet, and lifestyle of the person. But if a person is heading around sort of 12, for example, or below, and their serum copper is 22, because the range is 13 to 22, you're now looking at a potential zinc deficiency pyrrole metabolism issue. But that's not the only factor. They may have been sick in the last week with cold or flu. Look at the stress response of the person. And the other thing I do as part of my checklist is I look back at the research. Is there any aggression, anger, ADHD, depression, schizophrenia, etc., in the person's history, and also of their family history as well? Because as you know, a lot of health conditions are genetically derived or weakened, amplified in a person. It's not as simple as haemophilia, for example, but some health conditions can actually have a weakness in the body, like cardiovascular disease, and can pass down through generations. It doesn't mean it's going to happen, but it's more likely to in a person. So I've been reading up recently in a lot of forums, online forums, websites, podcasts, and just blogs, etc. So I do a lot of that in my spare time. And, we need to sort of look at the information that's valid and the information that is available to people and look at these testing methods. So, as you can tell, this is only just like a short snippet, isn't it, in this very complex health disorder. So I always say to people, think about the checklist that I just said. Are the levels greater than 50? And then think about all those signs and symptoms that I said earlier. Plasma zinc, serum copper levels, maybe look at the hemoglobin content, red blood cells, and general stress levels of the person and family history. And then that will actually start getting you somewhere.
Yeah, I don't know, from what you've presented today, Brad, you don't fill me with confidence about the test. I would so much prefer to have another marker that I could have some sort of confidence. I mean, even zinc is controversial. There's no agreed test on zinc, and it wavers in the literature depending on the year that you read the research. So we're still not there yet even with zinc, but I'd so much prefer looking at something like zinc, copper, even a B6 assay that at least has some reproducibility.
And glutathione as well, because these tests have been shown to be out of range with people with elevated HPLs.
They wouldn't be looking at glutathione, though, would they? They'd be looking at GPX?
Yes, and reductase you can as well.
So I just think I would so much prefer to have something that I could reproduce and to have some sort of confidence in any therapy that I instigated to have or to show whether I'm having a benefit for that patient or not.
That's correct, and we're definitely on the same page here. Is as a practitioner and educator, etc., packaging myself up, I like to look at all the information available before I start using it. And to me, this is a real health condition, pyrrole disorder or disordered pyrrole metabolism, as I like to call it with people to start explaining it. It's very complex. It's multifactorial. There's a lot of things going on. They've even found elevated histamine levels in patients with elevated HPL. So is there a link with allergies or histamine as a neurotransmitter?
Yeah, mast cell activation syndrome. That's something I'm interested in.
Yeah, so mast cell activated syndrome, couple that up with, the neurotransmitter link, the allergy component, the aggressive behaviour, ADHD, schizophrenia. Now we're getting a better picture.
Yeah.
But it's still not the picture. You know what I mean? It's getting there. But again, the research is not there for me to be, I can't stand here right now and say, yes, this is it. Because it's a condition, well, as I said earlier, pyrrole molecules have been researched since the 1920s. So it's not a new molecule. We've known about it for a long time. It's only really been since the 1970s. And again, in the late 1950s, it was noticed that people had what we call disordered pyrrole metabolism, which doesn't get mentioned anywhere. They just call it pyrroles or pyroluria. And one thing I always say to people is to be careful about websites or anywhere that has some kind of sensationalization of Pyrrole disorder or MTHFR or any of these modern health diseases that weren't talked about 10 years ago, for example, effectively talked about, because people use emotive language. They sensationalize things, and they use that emotion to, let's say, trap people into the diagnosis thinking they have this health condition. Now, there's not enough literature to show that the checklist that I've put together, that's my checklist. It's not the checklist that everyone uses because everyone's looking at their own thing. I've tried to capture as much as I can with my knowledge on the condition, but it's still not enough to cover everything.
Yeah. I think, okay, if there's a disordered metabolism, shouldn't we be looking back at that? Shouldn't we be looking at what's causing that? And I get that, sometimes you can go down a few rabbit holes to causation, but I just think, I think we need to take a step back from this and go back up the tree a little bit.
That's it. And we can look at disordered metabolism relatively easy with some basic tests, even just liver function tests, urea electrolyte, creatinine, like your mineral balance. There's a lot of tests you can look at that are standardized tests that measure metabolism in some form.
Yeah.
Then you can look at your stronger biomarkers, inflammatory markers, etc. So there's a lot of tests we can use that are actually called stable tests. They're highly recognised. Should we be testing these markers and combining the Pyrrole urine test, HPL? Should we be looking at, again, people that are diagnosed with these serious health conditions? Should we be going to institutions where people are being treated for severe mental health, for example, and having urine sample tested and check to see whether they have a higher HPL level versus someone who doesn't have these health conditions?
Yeah.
Or someone who's transient, who just has a bit of anxiety, and see whether it peaks in anxiety and changes during apathy or depression. So there's a lot of things we need to look at.
And women. We need to do more research with women.
That's right, because a lot of the tests, a lot of the research that people actually put online negate to tell you what the population was on. Yeah. That's one thing. They just say, we found these things. They didn't find it. The research found it. The person writing the blog.
In patients. Yeah.
That's a different story.
Yeah.
Don't get me started. They didn't do the research. Someone else did. But also, there's normally in age groups of, let's just say, under 25, mainly in boys. And as you know, puberty starts differently for boys versus girls. Hormone levels are different. They're still growing. Like, think of bone mineral density and peak bone mass is not until 21 to 25 in some people. So their body's metabolic rate is still working itself out. Yeah. Their brain and neurotransmitters, everything's still forming. So if we're relying a lot of testing on younger people and then saying, oh, that's for older people too, you know what I mean? It's like it doesn't correlate.
No.
Yeah.
Can't be transcribed.
So for me, it's very hard because I want to present the best information I can for this podcast, because I love FX medicine and the information that it presents to people. And we don't have enough on it to turn around and say, the tests are valid or invalid. We're still finding out this information. So more research needs to be done. We are doing some in Australia. I think it's in Queensland. We need more research being done in a wider range of age groups, male and female, different health conditions, healthy people as well. Yeah. So that way you get your reference range effectively there. And, should we be testing people, and this is very expensive, every day over a period of, let's just say, a month, particularly in females, to see if the amounts are directly related, or have to be longer actually, related to their menstrual cycle? Is it related to, in kids, during a school day or a weekend or school holidays or Christmas time when your family comes to visit and you got that person you don't like comes to visit or something like that? And it's like all these different parameters are not being looked at. Yeah. People just look at the number on the test and it says 25 micrograms per deciliter and that's enough. And to me, it's like, no, it's not enough.
Brad,
you need to look at the person, the patient, look at the person in front of you.
Seems like there's a heck of a lot more research to do before anybody can have confidence in this test. Brad, thank you so much for taking us through, which is a conundrum with the Pyrrole disorder and the Pyrrole testing. I'd love to hear feedback from our listeners actually on this. If you can, whatever the social media platform is, Twitter, Facebook, whatever. email us on info@fxmedicine.com.au if you want. We'd love to hear your feedback. I mean, I can get that this one's going to spark a lot of controversy, but if somebody's got some better research or a better play on it, please give us some idea, because the whole point of FX Medicine is to improve the skill set and the safety of practitioners out there. So, help us help you. Thanks so much, Brad, for taking us through this conundrum today with pyrrole disorder.
Thank you very much, Andrew.
This is FX Medicine. I'm Andrew Whitfield Cook.
Hi, I'm Dr. Mark Donoghue. Join us for our new podcast series, FXomics. We'll be exploring the new technologies of integrative medicine, including genomics, metabolomics, the microbiome, and many more fields that are transforming healthcare. We're focusing on how they apply to practitioners and how we can incorporate them into our patient care. We aim to make these exciting and sometimes challenging fields relevant to you and your practice. Search for FXomics on your favourite podcast platform, and we look forward to your company.